Assalamualaikum. In this group assessment for code FSC209 aka Food Engineering, we as a group will be presenting about gear pumps. Let me introduce to our group members. We have Siti Nur Hazwani, Nuliana, Nur Atika Ziana, and also myself, Siti Namda Husna.
So in this video, we will talk about introduction of pump, component of pump, operational principle of pump, application of pump, and advantages and disadvantages of gear pump.
The first one is about the introduction of pump, which is gear pump. A gear pump is a positive displacement pump that uses the meshing of gears to create suction and move fluid. It is one of the most common types of pump used in hydraulic fluid power application. Gear pump basically consists of two gears, either spur gear or helical gears, which are housed within a casing. The gears can have different configurations, such as external gears, where the gears are outside the casing. Or we have internal gears, where one of the gears is inside the other. For the working principle of the gear pump, as the gears rotate, they create voids or spaces between the gear teeth and the pump casing. This rotation effectively forms expanding and contracting chamber. During the rotation, the expanding chamber creates a suction effect, drawing fluid from the pump's inlet into the voids between the gear teeth. The trapped fluid is carried along the gear teeth as the gears continue to rotate. It is important to note that the meshing of the gears prevents fluid from flowing backward. The fluid is then pushed to the discharge side of the pump as the gears rotate further, where it is expelled through the pump's outlet. Gear pumps are categorized as positive displacement pumps. This means that for each revolution of the gears, they replace a constant volume of fluid regardless of the pressure. The positive displacement nature of gear pump is advantageous in application where a consistent and predictable flow rate is essential. It ensures precise control over the fluid being pumped. And then we move on to the operational principle of gear pump. Firstly, gear rotation. The gear pump's operation begins when the gears start to rotate. In most cases, the gears rotate in opposite direction. As the gears rotate, they create voids or spaces between their teeth and the pump casing. This rotation results in expanding and contracting chamber. During the rotation, the expanding chamber creates a suction effect. The suction phase rolls fluid from the pump's inlet or suction port into the voids between the gear teeth. The rotating gears trap the fluid within these voids. The meshing of gears prevents the fluid from flowing backward, ensuring a one-way flow. The trapped fluid is carried along the gear teeth as the gears continue to rotate. The rotation of gears effectively transports the fluid from the suction side to the discharge side of the pump. Then, once the fluid reaches the discharge side, it is expelled through the pump's outlet or discharge port.
So this is the video on how the gear pumps operate. Let's look at it.
Next are component of pump. There are two different types of pump, which is external and internal, which also known as grow pump. External gear pump has two identical gears with same size and number of the teeth meshed together, while internal gear pump has one inner gear, rotor, with fewer teeth meshed with larger outer gear, iron. External gear pump can be noisy due to gear clash compared to internal gear pump. It is quieter due to smooth rolling action. So here is the component of external gear pump. The primary function of drive gear and idler gear is to create the pumping action by meshing together and displacing fluid. Drive gear is connected with drive shaft and responsible for rotating the idler gear, while idler gear is not directly connected with drive shaft but is rotated by the drive gear. The function of drive shaft is to transmit rotational power from motor to drive gear. K-seal is to house and protect all internal components of the pump, and this seal sits between the idler gear and housing of the pump and function to prevent any leakage from the pump. Next is bushing. It functions to reduce wear and to the idler gear, which extending the component life. For mounting flange, its function to securely attach the pump to an engine or machinery to ensure proper alignment and operation. Lastly is suction port and pressure port. Suction port is inlet port where the fluid enters the pump, while pressure port is the outlet port where the fluid exits the pump. Next, we move to the component of internal gear pump, which is first is rotor and known as external gear. Rotor is smaller gear with few things that rotates inside the idler. It creates the crescent-shaped chambers that trap and move fluid. Second is idler, or known as internal gear. It is a larger gear with more teeth that surrounds rotor. It rotates at a slower speed than rotor. So here is crescent, and its function to prevent some leakage to occur and to maintain a tight seal. Next is housing. Housing is the outer casing that includes all other components and function to protect internal components from external factors and maintain pressure. Lastly is connecting shaft. Its function to maintain integrity pumping system and prevent the fluid from contamination. Inlet and outlet port has the same function as I said earlier, which inlet port is where the fluid enters the pump, while outlet port is where fluid exits the pump.
In the advantages, we can see gear pump are easy to use and their performance are easy to maintain. It is because of gear pump is compact and consists only of 2 gears. Therefore, compared with other pump, the gear pump has a small weight which is convenient for daily transportation and does not require much labor. It is also because of its lightweight, the gear pump is more convenient to use. At the same time, because of its simple structure and fewer components, it is more convenient to repair when problems are encountered. After that, gear pump have high work efficiency because it has minimal fluid slippage. Gear pumps operate on a positive displacement principle, meaning they move a fixed amount of fluid with each revolution. This design minimizes fluid slippage, ensuring that nearly all the pump fluid moves through the system. Also, it has consistent flow because gear pump provide continuous fluid. It has good work efficiency because of their simple design. Their straightforward construction with just a few essential parts like gear casing and bearing contributes to their efficiency. The simplicity of the design reduces energy loss. Move to the next. Gear pump have low cost, which can be one of the advantages. The gear pump is smaller in weight and easy to transport, which saves transportation costs to some extent. In addition, the gear pump is cheaper because of its simple structure. The maintenance procedure is simple and the maintenance cost is low. For the last advantages, gear pump can operate in high pressure. They can handle moderate to high pressure efficiently within their design parameters. Gear pump can be designed and manufactured to varying pressure requirements, making them versatile for different industrial applications. In this slide, I will talk about disadvantages in gear pump. First is pulsation. It leads to systems that can induce chemical vibration into the fluctuating flow of the fluids. As the gear rotates, they intermittently displace fluid, leading to fluctuation in pressure. These pressure variations can be problematic in systems that require stable pressure for optimal operation. After that, pulsation can disrupt the flow consistency by causing irregularities in the fluid movement. The second disadvantage is noise and vibration. The meshing and unmeshing of gear teeth in a gear pump can create mechanical noise. As the gear rotates, they produce a series of impacts which can result in high-pitched, wind, or a broader spectrum of noise frequencies. Also, the mechanical movement within the pump, including the rotation of gear and the movement of fluids, can transmit vibration through the pump structure. Next is gear pumps are sensitive to viscosity changes. For the thin fluids, it offers less hydrodynamic lubrication to the gears, potentially leading to increased friction and wear. For the thick fluids, the high viscosity fluids creates significant stress on the gears, requiring more power to drive the pump. And lastly, disadvantages of gear pump are it causes limited flow rate. Gear pumps have inherent limitation in flow rate due to their size and configuration, where gear pumps often have practical or material limitation on their operating speeds.
Application of gear pumps in the industries. Gear pumps can be applied in industries such as oil and gas industry, food processing industry, pulp and paper industries, and also automotive industry. In oil and gas industry, it is applied to be used to transfer crude oil, refining petroleum products, drilling mud, and also hydraulic fracturing, which is fracking in operations. Inside food processing industry, it can be used to transfer and dosing products such as chocolate syrup and other viscous fluids. Inside pulp and paper industry, gear pumps are used to manufacture pulp, ink, glue, and other fluids. Inside the automotive industry, it will be applied in automatic transmission system, power steering system, and also engine lubrications. It can also be applied in other industries such as the printing industry, textile industry, and also mining industry. It can also be used in hydraulic systems, chemical processing, pharmaceutical manufacturing, agricultural, paint and coating applications, plastics manufacturing, waste management, and also marine applications, including water treatment.